So we looked at the SAS, or side angle side congruence criteria, and we also looked at side, side, side. Well, we have two more that are very similar to that. In 4.4, we're going to be introduced to ASA, which, if you guessed it, it stands for angle, side, angle, and then AAS, which stands for angle, angle, side. It says suppose we have two fixed angles and one fixed side. So the side has to be in between the two angles that we know. It says, do these also work as congruence criteria for triangles? And when we look at this, here's an angle that is congruent in the two triangles. Here's a second angle that's congruent in the two triangles. And as long as it's the side that is in between the two angles, then we know that the two triangles are going to be congruent to each other. So I could say that triangle, let's call it ABC, is congruent to triangle. Since I started with A, I have to start with its congruent part, which would be D. And then I'm going to go to, then I went to B, so I have to go to E, and then F. So I would know if I have those specific parts, angle, side, angle, that the two triangles are congruent. And therefore, all of their parts are congruent. So I could name 3 angles that are congruent, and I could name 3 different sides that are congruent. Okay, how could we use this? It says a technician installs cables from a cell phone tower to the ground to pass inspection. Both cables must be the same length. Does this installation meet the cable length requirement? Okay, so if you look at this, what we need to know is we need to make sure that these two cables are the same length to meet the criteria. So what we want to know is, are these two triangles congruent to each other? Okay, well, we know that we have both of these angles are 52 degrees, so that's an angle that's the same. We know that we have a right angle at the ground here, which means we have a right angle at the ground on the other side of the pole as well. So we have 2 angles that are congruent. And then, of course, these 2 triangles, the one on the left and the one on the right, are sharing that side. Since they're sharing the side, it has to be congruent to itself. So based on the fact that angle, side, angle, we have an angle, a side, and an angle on each triangle. Those 2 triangles are congruent. Therefore, these 2 sides would have to be congruent as well. Let me put 2 tick marks there since I've already used one. But we know that these 2 parts would have to be congruent. So yes, that would meet the criteria or the requirement. Okay, and not only do we have angle, side, angle, but we also have angle, angle, side congruence theorem. Okay, it says that if 2 angles and a non-included side. Okay, so AAS stands for angle, angle, side. Now this time the side is not in between the 2 angles. You're going to see consecutive angles, and then you're going to see a side. In that situation, we also have congruence. So I could say that triangle JKL is congruent to triangle. Since I started with J, the angle over here that's congruent to J is Q. Okay, and then I went to K, so I'd have to go down to R and then up to P. Okay, those 2 triangles would be congruent to each other based on angle, angle, side, and therefore all their parts would be congruent to each other. So we have a total of 4 different congruent shortcuts. We have SAS, which stands for side, angle, side. We have SSS, which stands for side, side, side. We have ASA, which stands for angle, side, angle. And we have angle, angle, side, which stands for, or we have AAS, which stands for angle, angle, side. Okay? And you can see that those are listed for you right here. We now have a total of 4 different criteria. If we can find those specific parts in triangles, then we know that the whole triangles are congruent to each other. Okay, we're going to look at these 4 specifically. Okay, so if you look at the pictures, which parts are marked as congruent? You see an angle here, you see this angle, and then you see the side. So you have 2 angles and you have 1 side, and it's really important the order that you see this in. You see that the side that is congruent is in between the 2 angles. So that has to be angle, side, angle. Okay, this drawing over here, what do you see? We see tick marks here. Here's another set of sides, and here's the third set of sides. So since all we see are sides here, we know that that is going to be side, side, side. Okay, this bottom picture, we see an angle, then we see another angle, and then we see a side. Now, is the side in between the two angles like it was up here? No, the side is not in between the angles, so this criteria would be angle, angle, side. It's important. These are different. Okay, in this one, the side has to be in between the two angles. In this one, it does not. Okay, and then lastly, you've got a side, you have an angle, and then you have a side. Now, this is kind of a trick here. On this triangle, the angle is in between the two sides, but is the angle over here in between the two sides? And the answer is no. So these are not, those are not congruent to each other. All right, why don't you give that 4-4 worksheet a shot and join the Zoom, because this is not easy stuff. We're getting into proofs. Please join the Zoom so you can ask questions.